Thank you. Yep, I'll be talking about our open source mapping stack. So to get us started, I'm just going to talk through what is our Abley SafeSystem product, present the architecture to you, give a bit of a demo, and then going to go through some challenges we've encountered with the stack and some resolutions that hopefully will help you guys. So Abley SafeSystem is a suite of products that's working to apply best practice proactive road safety research to save lives. So the SafeSystem approach is kind of a global approach for road safety that's around reducing deaths and serious injuries by kind of admitting that people make mistakes, but they shouldn't die as a result of those mistakes. It takes a proactive approach to identify dangerous locations before people are killed. Now, we are predominantly targeting our sales into the US at the moment for this product. And the product is sort of based on data products and then applications that present the data and power actionable insights that road safety engineers in different jurisdictions can use to actually fix these road safety problems. The suite consists of a couple of different products. And then within each product, there's modules that align with the Federal Highway Administration's kind of guidance as to how they should look at and treat road safety problems. So Safe Curves identifies curves where drivers are likely to be driving faster than they can safely negotiate the curves. We then prioritize those curves into corridors, which have like a, hey, this is the first kind of area you should start looking. And then interventions is showing them places, or specifically what they can do, like put these kind of signs in here. Same kind of idea follows through all the modules that they can. So Safe Roads, they're kind of looking at road segments specifically, and they can actually test countermeasures. And we've got a whole bunch more in the pipeline, targeting different kinds of road safety teams. So the architecture of the stack begins with our, I guess, the design intent is really around, it's a data product, so we need a geospatial platform that will host the data. It will support multiple applications on top of the platform, as well as enabling GIS services. So the primary thing we're still trying to sell is essentially data, and the applications are almost a bonus. So a lot of big organizations are GIS savvy, and they want to pull that into their desktop GIS applications. Some smaller jurisdictions wouldn't have a single clue about GIS, probably only know spreadsheets, and they love the applications. We need the user management and licensing to be sort of flexible and in our control, and we need it to be performant. So to kick off, at the start of the project, we had this idea, we were trying to build this thing, and initially I just had to start exploring a lot of different alternatives as to how we could do things. Could we get away without having to even really host the data, using a platform that already hosted it for us? We've ran into a few issues there around user management and performance within the applications. Kind of looked at a few things for having no GIS server, but we wanted to keep it simple in the first stages and build out the complexity application later on. And you might have seen my colleague Luke talked about different web mapping libraries that we investigated before, and we ended up picking MapLibre. So our approach across the architecture we chosen was to start really simple, even if that's manual, and then improve things and automate when it gets painful. In the end, this is the current architecture. We've got a PostGIS database feeding into GeoServer, and that is providing our operational or secure layers. And so we actually have all the US data loaded into the one database instance, and we use view layers per user, basically. And at this point, as part of our keeping it simple, we're just using API keys. So every organization just shares one API key. That points them as a GeoServer user into their view layer, and that really simply pulls through into the apps and to the GIS services just with their API key. We're not planning on keeping that model for very long, but it works for the moment. And on the side, we're also running an MBTileserver that just gives us some context layers, and they're kind of secured in that they have something that looks like an API key. We're not too worried, and that data is shared with everyone. So as I mentioned, part of keeping it simple, we're sticking with API keys, we're kind of treating GeoServer as a bit of a Swiss Army knife at the moment. It's doing our GIS services, can do feature requests, of course, and it's serving vector tiles using the GeoServer vector tiles extension. Currently, we're running our database in Docker. It works and is actually pretty quick at the moment, but longer term, we've got plans to move that out. And currently, the process for loading our data into an instance is it's not terrible, but it's not great either. It's not particularly automated. Cool, so now I'll demo the application. The initial screen you land on is this dashboard that's got summary statistics about the road network and curves that have been identified in the area. And that takes you to a map view. So here we're showing all the corridors by priority. Sorry, but road safety engineers really love this black, red, green color scale. So it's a pretty prominent theme throughout. But you can see on here we've got black corridors are the most unsafe ones through to green, the ones you wouldn't worry too much about. The app's got a table view where you can see some of the properties, and you can sort by anything and jump back into the app. Now I've picked the highest priority corridor in this jurisdiction. You can see the attributes there, and down on the side we've got countermeasures. So that's starting to get into the what can they actually do about it. Or if we take a look at our curves specifically, can turn that later on and open that guy up. Once again, we've got attributes, and here we can get into a bit more detail about the kind of countermeasures that could be applied. And this one has to ask them a question depending on how many crashes that curve has had in the last 10 years. It makes some different recommendations. And so there's some things that they're required to do by the Federal Roading Agency, some things that are recommended, and some things they could consider if maybe even after doing the other things, they still weren't seeing the road safety benefits they would expect. And additional to the web app, the main apps, we've got a GIS services application. And this one simply puts out GIS services, so it makes it easy to get into desktop applications, lists all the different services. They can see on a map, yeah, this is kind of what I'm looking for, and then lots of different ways to connect. Now, because we're generally dealing with less technical people, and the ArcGIS penetration in the US seems to be quite high, we do provide LayerX files, so they can easily just download those into ArcGIS Pro. Cool. Now some of the challenges we've encountered building out this stack and continuing to grow it. Docker Compose is really cool. It stands up all parts of our API stack. It includes the basic configuration of the services and containers, and having configuration as code, so it's in your source control, is really powerful. I'm probably not teaching anyone anything new here. One thing we've noticed though is that local dev is pretty much like production, which is really handy, but we've been using Docker on WSL on our laptops, and it turns out that's not actually that much like Docker on real Linux, especially if you're trying to monitor exactly what processes are doing. So, if you're running top on your Linux, you could actually see GeoServer's Java process and what it's actually doing. On WSL, you don't get the same things. Another bit where we put quite a bit of effort in is that GeoServer in a Docker container initially comes with a lot of, undesirable defaults, like a weak password storage method. The admin password is GeoServer. GeoWebCache doesn't have data security on it. And there's some unnecessary, for us at least, services and formats supported. And I guess normally as post-install steps on a server, you would go through and configure all those things, but we obviously want to do it, part of how when we roll out a Docker container. So we made a scripted environment bootstrap step that actually uses the REST API and particularly the settings API, which lets you get settings, adjust them and put them back, or in particularly one that we didn't find until a little bit later on is the resource API, and that actually lets you get basically any file that is in GeoServer's data directory, and then you can manipulate that and put it back. So that one's good, especially for some of those deeper security things, which are a little bit harder to change. In terms of desktop integration, WMS and WFS and WMS, they're open standards. They're generally well supported. We started playing around with the OGC feature, map and tiles APIs. When I first started playing with it, I thought, oh, these are the latest thing, I'll dive right in. But they were probably still a bit immature a couple of years ago. I think they're continuing to evolve, probably worth another look. A big push for us was keeping it simple for less technical users, but at the same time, they still need the power. And that's where, as I mentioned before, we've got our download buttons so they can get it straight into ArcGIS. You notice I've got 2 download buttons for ArcGIS. It turns out less than 3.4, they used to escape dashes in the WFS layer name with underscores, but 3.4 and above, they don't. So that kind of broke everything for a while. Vector tiles is the format that we're serving both our kind of contextual data and operational data into the app. Because attributes can be included in vector tiles, I mean, you can click on it and the data's right there to show in a pop-up. If you noticed before during the demo, the table loaded really quickly. I'm actually just taking all the vector tile attributes that are shown from all the features that are shown and chucking those in the table. So the table loads instantly. And that's been a pretty cool hack for the moment. There's a few caveats, though, that we've encountered, mostly not from any real users who are using it, who are zooming in and going to a state or a county, but our CEO, who's our main sales guy, likes to load up the whole of the USA and then zoom and pan around. So that means we've got to generate tiles for the whole USA. Because we've got lots of attributes on our tiles so that we can do cool things like make the table load quickly, that's actually been crashing our server. So yeah, thinking about attributes at low zoom levels has been a bit of a challenge, and I'll mention that in a few more slides about how we're going to, some ideas for working around that. And the other thing is, if you can see on this screenshot here, this is one curve in 2 directions, and on one side of the road, it's nice and continuous. On the other, you see it looks like it's been cut weirdly. And this is actually to do with tile buffers. So the data actually comes in just up the center of the road. We're offsetting it so that it looks nice and the user can see what side of the road we're talking about. But GeoServer's vector tile extension generates tiles with a 5-pixel buffer around the outside. MapLibre, when it renders, clips anything. So if you give it a wide offset or make a line with a high width, they actually get clipped to the tile in which they reside in. So that's what we see is happening here. I've offset this by like 40 pixels, and it's overflowed the tile and been clipped. That was actually a slow-burning GitHub issue for a long time. I kind of made a custom fork of MapLibre with a few hacks in it to get around that, and I talked to Gemini, and it told me I was really cool and was going to be able to fix this problem really easily. So I thought at this presentation I was going to be talking about how I made a pull request to MapLibre, but it turns out Gemini was hallucinating. Yeah, and in the end I ended up just making a change to the style documentation to say, hey, if you've got this kind of problem, this is where you need to start looking. And so the real solution, either you could use our hacky custom fork, or you can change how you're generating your tiles, include a bigger buffer, would be the main way to go. And yeah, as I mentioned, tile caching, it can be quite expensive to build a big cache. I mean, it's not a new problem. In our case, we were actually running out of memory on our EC2 instances and bringing down the whole instance, it would completely lock up. We had to do a bit more tuning around the JVM heap size and things like that. So there's a bit of a work in progress around being smarter about server side. You know, can we build the tile cache ahead of time and just upload it? Can we use an alternative vector tile building library while keeping it within GeoServer? Could we make a display-only layer so we're not having to worry about tiles with lots of attributes in there? Or can we be smarter about client consumption, think about different formats, maybe just consume images when you're zoomed out and switch to vector tiles as you zoom further in? Or, you know, as you pick up a lot of stuff at FOSS4G, do we move away from using GeoServer to serve our vector tiles and get some crazy PM tiles or something in there. Cool, and that's really the guts of the talk. So in summary, we've felt like we've had good results from taking an agile approach. You can always make it more complex later. I've really personally enjoyed working with vector tiles. They've been just handy, fast, and having the attributes right there is really handy. And the stack that we're working in has been really fast and fun to work with. So thank you.
We've got plenty of time for questions, so does anyone have any questions for Stacey?
Cool, thank you. Awesome presentation. Quite curious about the app, I guess, not so much in the technical stuff because this is things that I don't really work with. When users choose like a road that they need to do something with, like, do they have a way of creating like a portfolio of things that they then do? Like they can just add this road to the next set of stuff that they're actually going to implement.
Yeah, so not right now. We're still quite early, mostly demo stages, but that's definitely on the roadmap. So right here we've got a corridor. On that corridor you've got curves that you need to treat, and then there are the interventions for those curves. So yeah, being able to build that out into an entire program. And one of the interventions, which I forgot to show, is around signs. So the app actually says, here's all the signs you need on this road, according to the Federal Highway Administration in the US. So it can give them almost a bill of materials of what they would need to go and put on that road. So yeah, that's all in the roadmap plan.
Oh, cool. And then presumably, like, once they have implemented these things, they'll be able to do some evaluations of the crash improvement. Yeah. Cool.
Question I have while we wait for other people to ask questions, and apologies if it's a really bad question, Stacey. I am just curious, why did you guys, I guess, go for an open source stack? I know that's a bit of a self-serving question, but I am just a bit curious. Because in theory, you could potentially use this using proprietary software. So I'm just curious why you've chosen an open source stack.
The big one for us was having a bit of control over it, particularly user management and licensing. So we want to be able to sell it as a data product into an organization that has, their own users and potentially other consultants and things like that. And certainly the proprietary solution that we're most familiar with is not very supportive of those kind of, shenanigans. Doesn't give us the flexibility, I guess.
Cool. I think one final question I have, and might be a good way to wrap it up, unless of course anyone's got any other questions you want to ask Stacey. You mentioned a little bit in this talk around about some changes you're thinking of making, and I'm just curious exactly what changes. You mentioned like when you showed the stack that you guys are looking at changes to it. I'm just curious if you could share what changes you're thinking of making or exploring with your architecture.
So right now, big one is that it's secured with API keys. Our plan is to go to user logins. Done a lot of testing for that, but we haven't rolled it out yet. And yeah, the other ones are, from there, I think it's how we're serving those vector tiles. So they're good enough for the moment. And I think because it's only really it's only creaking when the CEO wants his all USA view, and particularly when it's a fresh instance and it's building the tile cache, maybe we can just give them an image layer and that will come straight from GeoServer, no worries, and we just won't have to think about it. No customer's ever even going to see it, so it wouldn't really be a problem. But when we look going forward, I'm kind of thinking something that was going to give us that secured vector tiles that we can serve straight into the app of our operational data, and GeoServer might be just doing our API services.
All right. If that's the case, if there's no other questions, then please give once again a thanks to Stacey for his presentation.